just thought of one more thing we should actually look at here. And so I want to do the example of what happens if, instead of a escape pod here, what if Bob has a flashlight or laser beam and he shoots a beam of light out in front of him? So let's just quickly do that. In fact, you might want to turn off the video or pause the video here for a minute and just try that situation. In other words, u sub r, which has been the velocity of the escape pod, what if that was just a light beam, so at the velocity of light? So try that if you want, and we'll do it right now, actually. So u in the rocket frame is going to be a beam of light, so it's just going to be c. And again, you may guess that we're going to get a similar result to what we've had before. In fact, we should get, let's think about what we should get here. If Einstein is right in his principle of light constancy, which combined with the principle of relativity led us to the idea that the speed of light is constant to all observers. It's the same value for all observers. That means that if Bob sees that beam of light going out from his ship at c, then Alice should also see that beam of light going out at velocity c, even though that's not intuitive. We'd expect the velocities to add. The velocity of light should be c plus the velocity of the ship. Let's see if the equation tells us that or not. So u sub r is going to be c. So I got c plus 0.9 c. That's the relative velocity of the ship. All over 1 plus u sub r is c here. V is 0.9 c. All over c squared. Okay. So what have we got here? On the top, I've got c plus 0.9 c. That's 1.9 c, 1.9 times c. And on the bottom, look what happens. Okay, I've got a c here and a c here, so I've got c squared divided by c squared. Again, that cancels. And I've got 0.9 left. So I got 1 plus 0.9. And of course, that's 1.9. I've got 1.9c divided by 1.9. Just to make it clear, 1.9 times c divided by 1.9. And that, of course, is just c. So it does check out that this velocity transformation equation between the two frames, the velocity in one frame and turn it into velocity in this case, the lab frame, then if it's a light beam, it still is c. So we've just demonstrated that it is internally consistent, that the postulates Einstein started off with, one result of which was that the velocity of light is always c to all observers. Yes, this equation checks out with that, which of course is good news, because if it didn't, then we'd have to figure out what went wrong along the way here.